All right, this is lesson 6, and for lesson 6 today, we're going to talk about decision analysis under the case of risk. And what this means is the following. Decision making under risk means that probabilities can be assigned to future outcomes. I apologize for the phone. Probabilities can be assigned to future outcomes, and there's two tools that we're going to look at. The first is expected value of information, and then the second one is the expected value of perfect information. And what would we do if we actually happen to have perfect information? So let's dive in, and we're actually going to continue with our same example. And again, we've got three decisions that we need to pick from, and we can only pick one. We'll either invest in the apartment, the office, or the warehouse. But now we have information about the future states. You know, last time we said we had no information, which means we would have to our best guess would be that each one of the future states of nature, the chance of that happening would be a third, or 33%. But now we have additional information. In fact, we've got information, and we know from among these three future states of nature that the fair economy is 70% chance that the economy will be fair, which is most likely that will happen. But then there's also a 20% chance that the economy would be good, and then there's as you can see, a 10% chance that the economy would be poor. So there's a chance that any of those three could occur, but now we know, we have information from analysts or other sources that it's much more likely that the economy is going to be fairer than the others. And as you might imagine, since we're given these probabilities that are much like those determinations that they're equally likely, we're going to do the same similar type of weighted average calculation for each one of these alternatives. And so for the apartment, we're going to calculate, again, calculate the value. If the economy is good, there's $50,000, and there's a 1%, or excuse me, not 1%, a 10% chance that will occur. Plus, for $25,000, there's a 70% chance that this occurs, 0.7. And if the economy is poor, we'll return $10,000, and there's a 10% chance that will occur. And when we do those calculations, it turns out that this value is 28,500. This is actually called an expected value. And so we're calculating actually calculating the expected value, EV, of outcome A. Well, then we'll do the same thing for the office, and actually expected value for the apartment. And so then for the expected value for the office, again, it's going to be similar. We'll return, there's 100,000, and there's a 10% chance that we would have that return. Plus, there's a 70% chance that we would have $20,000 return if the economy is fair, and then we would lose $50,000 if the economy was poor, and that's, again, we've got a 10% chance that occurs. And when we do the arithmetic here, it turns out that this is 29,000 even. And then, of course, we're going to calculate the expected value for the warehouse. And we'll return 30,000 if the economy is good and there's a 10% chance that that occurs. And we'll lose 10,000 if the economy is fair. And we will return 15,000 if the economy is poor, but there's only a 10% chance that this would happen. And when we do the arithmetic, this turns out to be $500. So now there's a couple of points that I want to make here. Before I do, clearly the decision that would be recommended would be the maximum of these three values. And of course, the maximum of these three values is $29,000. So as we've done before, our decision would be the office and expected value of the office is 29,000. So we choose, again, we're going to choose the maximum of these values. All right. So the points, a couple of points that I want to make is what I want you to notice is, first of all, you would never achieve if you invested in the office, you would never return exactly $29,000. You're either going to return 100,000 or 20,000, or you're going to lose 50,000. But on average, if you repeated this 10 times, if you were able to invest in the office 10 times, well, you would return $100 once. You would return $20,000 7 times. Oops, I've made a mistake here. This is hopefully you've caught this, a mistake here. It's not 10% for good economy, it's 20%. So this is 0.2. And so instead of returning 100,000, you would return 200,000 because you would get $100,000 in 2 cases. You would get $20,000 on 7 days, 7 of those investments, and you would lose 50,000 on one investment. And if you can see, this is 100,000 on 2 days, plus 140,000 for those times that the economy was fair. And then you would lose 50,000 on that one time when the economy was poor. And of course, this 340,000 minus 50,000 is 290,000. And then, but this is going to be divided by 10 because you will have had 10 days. And so on average, you would receive this $29,000. Hopefully that makes sense. And I apologize for this error because this is 0.2 in each one of these cases, not 0.1. But hopefully I'll help you remember that. So again, back to this, we say the expected value is of vesting in the office is 29,000, but that you have to assume you're able to make this investment over and over again, or have similar investments over and over again, because this represents an average return, not the individual return. And again, when we were not able to assign probabilities, we dealt with individual returns, and we looked at that on a case-by-case basis where you actually would return those. And so this is an average value, which is the key point. Right. So next, we know what the expected value is, and I'm going to keep this up in the corner here. We know that the expected value of the office is $29,000. Keep that in mind. And now we're going to look at the case. We're going to try to compute, we will compute what is the expected value of perfect information. Right? So let's suppose we were able to go out to an analyst, and we know that this analyst was perfect. If the economy were going to be good, that analyst will report that the economy is good. If the economy was fair, is going to be fair, he's going to report that. And if the economy is poor, he will or she will report that. So let's determine, first we want to determine the expected value of this decision given we have information, give us information. All right. So if we go to our analyst and the analyst tells us the economy is going to be good, what will we do? What will our return be? Well, in that case, we'd invest in the office and the return would be $100,000. If the economy if the reports that the economy is going to be fair, we would invest in the apartment and the return would be $25,000. And if we were to invest in if the analyst told us that the economy was going to be poor, we would actually invest in the warehouse, and we would because that would return $15,000. That's in each one of these cases, that's the best return given the economy, the largest return given the economy. But of course, now we need to remember that if this analyst is perfect, the report will tell me that the economy is going to be fair only 20% of the time. And so our actual return given this information would be 100,000 times 0.2. And the analyst would tell us that the economy is going to be fair 70% of the time. So in this case, we would return $25,000, and we would return that. We would make the investment correctly every time he told us that the economy was going to be fair. And then if the economy were poor, we would return $15,000, and he would tell us that 10% of the time. And when we do these calculations, do the arithmetic, our expected value given this information, it turns out to be $39,000. Expected value, and let's get my terms. This is the expected value given perfect information. All right. But now, what we need to know is, and hopefully, the important question is what is the most you would be what's the most you'd be willing to pay for this information? And think about this for a minute. What is our expected value if we didn't have information? Hopefully you remember that the expected value of this decision without any information corresponds to our expected value of the office, which was $29,000. I'll write these up here. This of the warehouse was 500, and of the apartment was 28,500. And so hopefully you would realize the most we would pay, expected value of perfect information, not given, but of perfect information, is the difference between the expected value given perfect information minus the expected value without information. And so in this case, it's 39,000 minus our 29,000. Which is, of course, 10,000 which is the most $10,000 is the most we would be willing to pay for perfect information. And of course, we'll never get perfect information. So if you went to an analyst, you would, in this particular situation, you would never pay more than $10,000 for this information. Now, hopefully you can see that this is because of the arrangement of the information and the data, and particularly all of this can be computed easily in Excel. And this is a sample spreadsheet, and I'm going to, in the next portion of this lesson, I'll show you how to manipulate and what formulas to use in making these calculations in Excel. So we'll after this another slide or two, we're going to dip out and talk about Excel in the next portion of this lesson. And then what I would like for you to do is to go ahead and to work through. We've already talked about the first part of this problem where we talked about telecomp and with the conditions of uncertainty. And now we're going to also ask for you to go ahead and do this calculation under risk, and I will put the solutions to these up. So let's go. Let's end this lesson, and then I'll by the way, this will be the solutions. I'll put these solutions up. But for right now, let's end this lesson, and let's go look particularly at Excel and see how we can use Excel to calculate these solutions.